Hello students, this video is about graphing logarithmic functions. So when you're graphing these, there are three things that I want you to keep in mind. First is that this graph has a vertical asymptote right here along the y-axis. Okay, it has a vertical asymptote, which means that the graph is going to get closer and closer and closer to this line without actually touching it. And that vertical asymptote is going to move with transformations of the graph. The next thing is this point 1, 0 is always on the parent function. Here's 1, 0. Now the reason that that point is there is because the log of 1 is 0. The log of 1, no matter what the base is 0 because anything to the 0 power is 1. So we can always include this point on our parent function. And then lastly, there's another point that can always be included on the graph, and that is where the function is equal to 1. The function will be equal to 1 at when x is the value of the base. So in our equation, we can see that since there's no base here, the base is 10. That means that if I come out to 10, that the function is up 1. So whatever the base is, I can come over that much from the asymptote and come up 1. That point is on the parent function. So when you're drawing these graphs, I want you to include those three things: the asymptote, the point at 1, 0, and the point that's at the value of the base. Let's look at some examples of drawing graphs of logs. Okay, so for our first example, let's see if we can draw a graph of log base 5 of x. So I have my coordinate system, and first of all, I know that this graph is going to have an asymptote right at the y-axis. Now, I also know that for my parent function, it's going to pass through the point 1, 0. Now, since the base is 5, I'm going to come over 5 from the asymptote. It will also pass through this point. Now, with just those 2 points on my asymptote, I can draw the graph. Another example. Okay, now let's see if we can draw the graph of log base 7 of x plus 3. So, this time I can see that we have this plus 3, a transformation has happened to the graph. How will that move the graph? Well, since the plus 3 is inside here next to the x, I know that it's going to move horizontally, either left or right. And the x values always move opposite than what's expected. So instead of moving plus 3, this is actually going to move to the left 3. So I'm going to put my asymptote left 3. Move it over 3. All right, so now let's put the parent function points. I know that the first point is usually at 1, 0. So starting from my new asymptote here, I'm going to come over 1, and there's my point. And then, since the base is 7, I can come over 7 from my asymptote and up 1. And once I have those 2 points and my asymptote, I can just draw the graph. Okay, for this example, we're going to see if we can graph negative log base 3x plus 2. All right, so we're going to start with our asymptote. And I know that my vertical asymptote is at the y-axis. Now I have to consider the transformations of the graph. Looks like this plus 2 is outside of the x values, so it's going to affect the y values, moving the graph vertically. So the y values move as expected, so I'm going to move the graph up 2. However, that's not going to change my vertical asymptote. Your vertical asymptote will still be in the same spot. All right. Now I also need to consider this negative. So this negative is in front of the function. Again, it's not inside here where the x's are, so it must be affecting the y values. This is going to make all the y values negative. Making the y values go from positive to negative is going to be like a reflection over the x-axis. Okay, so that again is not going to change my asymptote. And not only that, it also won't change the point from my parent function, which is over 1. All right, so now I'm going to put my next point in, which is the base here is 3. So that means I can come over 3 from my asymptote, and then I usually come up 1 to put my point. Now, instead of coming up 1 though, because of the negative, I'm going to reflect this, and I'm going to come over 3 and come down 1. It's actually going to be here. So instead of hugging the asymptote here, it's going to come up this way. And there's my graph. So what we can see here is that all the transformations that you guys have learned past, when you were doing quadratics, when you were doing lines, you've been studying transformations. Those same things hold true here. So if you have a value that's added inside here next to the x, we know that inside changes the graph horizontally, and that x's move opposite, this would move the graph left 2. But if the 2 is outside of the x values here, it's going to move the graph vertically, and that the y values move as expected. This is going to be moving the graph up 2. Having a negative in front here, in front of the graph, again, this is like the y values because it's outside. So on the outside here, this makes the y values negative. Making the y values negative is like a reflection over the x-axis. Whereas if the negative is inside here next to the x value, then it's going to make the x values change from being positive to negative. And changing those x values is like a reflection over the y-axis. All right, if we multiply inside here, multiply next to the x, instead of multiplying all the x values by 3, the x values happen as opposite again. So this is like dividing all the x values by 3. And if we're multiplying out front, outside the function, then that's the y values. So this is multiplying the y values by 3, which is a stretch. So with graphing logs, all the transformations that you've learned are still apply. And you should graph it by considering the parent function, graph that asymptote, and then add in those 2 points from the parent function that I was just describing so you can draw in the graph. Great. Let's practice that in class.